Is that clear? So I'm gonna just solve number one for yours using the first principle, just so you have, an idea of what first principle entails. All right. Then I'm gonna spice it up with the formula method, which you must, of course, know, because if you're not using your first principle, you must use your formula method. So let us see what we got. Now we have number one to be a function of x equals x squared, right? Now how do I look for my derivative? That is, how do I look for my f prime of x? How do I look for my dy dx? As it has been said earlier on, that dy dx equals f prime of x. What does that mean? That is to say that my dy dx is the same thing as saying my f prime of x. So just in case you come across it, these is equals to these, or these is equals to these. All right. So with that being said, so this is a function of x being equal to x squared. So using my first principle, how do I look for my dy dx? How do I look for my f prime of x? Now, the formula to look for your f prime of x or dy dx using your first principle is this: y plus change in y equals x plus change in x. So note these. All right. Now, do you see y plus change in y here? So all I'm trying to say is that this function of x could be as well written as y equals to x squared. Okay, so if you have that, that is to say that anywhere you see y here, you replace it with y plus change in y. And anywhere you see x here, you would replace it with x plus change in x. So therefore we have y plus change in y equals x plus change in x raised to the power of 2. Okay, so with that being said, we need to find the expansion of these, of what we have at our right hand side here. Y plus change in y equals to, the expansion of this would give me x squared plus 2x change in x plus change in x of this power of 2. If you look for the expansion of what you have on your right hand side. So that means that at these points, you need to subtract y from both sides. And if you do, what do you have? You would have change in y equals x squared plus, I'm writing the element here, change in y plus change in y, change in x, over power of 2, minus y, as it has been said. Subtract y from both sides. Okay, but then going back to what I have here, my y was what actually x squared. So minus x squared. Now at this point, something was cancelled out. What do you notice? X squared would nullify out x squared. Okay? So what is left is changing y equals to 2x changing x plus changing x all raised to the power of 2. So at this point as well, what you need to do is divide both sides, that is your left hand side and your right hand side, by changing x. So divide both sides by changing x. So yeah, divide both sides by changing x. So once you do, what do you have? You would have changing y divided by changing x equals to 2x changing x divided by changing x plus change x raised to the power of 2 divided by changing x. Do you see that? Alright, so with that being said, now what do you have here? Of course, you have changing x, nullifying changing x. And here, it's like you have changing x multiplied by changing x. The product of changing x and changing x will give you changing x squared. So this is to say that these will nullify one of these. So this is remaining just changing x. So at the end of the day, what do I have? Now I would have changing y divided by changing x equals to 2x plus changing x. Alright. And I hope you know what this little triangle stands for. This is called the delta sign. We call it the delta sign. I'm right here. Okay, so it's called the delta sign. Okay. So with that being said, at this junction, what we now need to do is we need to find or take our limit as changing x tends to 0. So limit as changing x tends to 0. Now that's a very dealt with limit of function, limits and continuity in some minutes back. Alright. And you know what we did when we was looking for our limit? Anything, any variable, whatever, we say it's tending to 0, approaches 0, we insert that number, the variable is approaching, into our function. So in this case, changing x here is replaced by 0. So I have now, as well, once you're taking your limit, at this point, once you take your limit, as a changing x will be tending to 0, likewise, understand that your changing y, changing x, would be tending to divide the x. Okay? So now I would have divide the x, like I said, as changing x is tending to 0, this is tending, so I would have divide the x equals to 2x plus 0, and the sum of that is 2x. So you can see the whole process, and you can see the number of minutes it took me to actually look for the derivative of that function, y equals to x squared, or f of x equals to x squared, using the first rule. Like I said, you don't need to go through all of these in, during exam. You don't need all of these during exam at all. So what do you need?